All right, here we go. Part 3, human tissue. Amazing stuff right here. So I hope you're ready for a good journey. We are, as we mentioned, part 3 of our walk through, our journey, our pathway through human tissue. Lots of stuff. I mean, lots of stuff, lots of great stuff. We're essentially, through this process, talking about almost every part of the body. So, hope you're ready to jump in, strap up, and get going on this pathway. A lot of stuff, as I mentioned. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 topics to cover. So it'll be a little bit longer than that last one, which is about 33 minutes. So, but hopefully less than an hour. But we'll see. So with that, welcome A&P students. Thank you for being here. Thank you for connecting in this manner. Hope you enjoy this. Look forward to talking about it in class. And with that, we will get started. All right, we're zoomed out pretty good. Let's get in here where we can work at a decent amount. One more. Always like to be at that 62 spot. That's about the right size of everything. So let's see if I can't get all this on here. And now from this, we just got to go down for everything. So again, welcome. Thank you. Love you guys. Appreciate you guys. Thank you for being a part of this, your educational journey. I'm enjoying myself. You guys are great. Classes have been great. You guys are pretty enthusiastic and pretty engaged and interested. So, as well you should be. For probably 90% of you, it's a direct correlation to your career path. And with that, let's get started. All right, areolar tissue, as you can see here, and we're going to talk about the different parts here. But let's, again, just like last time, just so we can clearly read what's being written down here. We'll type this out for you. But areolar tissue is loose fibers, not hard, compact. Oh, not figures. Glad I didn't spell a bad word. There we go. That would have been. I basically would have just stopped and started over. So that's how to solve that issue, and just put that in the trash can. Loose fibers. We are lots of blood vessels. Lots of blood vessels there, keeping it just, healthy, vibrant, alive, all that stuff. It has all 6 types. It's all 6 types of cells. That's really kind of a misnomer. Really, there's 2 classes and then 3 types. And so we've got them all. So we're talking, it's got squamous, it's got cuboidal, it's got columnar, and it has simple versions of that, stratified versions of that, and that's where you get the all 6. So what I'm trying to say is that, it's going to have simple squamous, stratified squamous, simple cuboidal, stratified cuboidal, simple columnar, stratified columnar. So that's what we mean by all 6 types. And super important here. Make sure I'm spelling this right. Lays on areolar tissue. So every type of tissue, it's on top of the foundation of areolar tissue. Now let me scoot this over just a tad on the picture here, and I'm going to clear out of that, because now let's write a little bit Let's go back to, let's get green. We haven't used green in a while. So let's get some green. So let's identify some of these parts here. This stuff right in here, this lighter stuff, that's ground. And yes, I'm writing it, writing it with my mouse, not typing it, but that's all right because we're just doing one word descriptions. This is ground tissue, right? Ground tissue. Yeah, ground substance is what I meant to say. Ground substance. So if you'll remember, ground substance was that stuff that attached, held on to stuff. So within that section, you're going to have the parts that hold the tissue together, but also hold the components of the tissue together. But if you want to roll back up to our section or to our part on ground, that was in the connective tissue, the previous one. You can see that, or just look at your notes. That'd probably be an easier way of doing it. All right, so these lines, and I'm going to draw on one here, like that right there, and that right there, and this one going here. Those are all, let's come down here, those are all elastic fibers. And yes, this is why I don't, if I got a bunch to do, I type it out. That's supposed to be a C there. Let's try that again. There you go, elastic fibers. So the idea there, obviously, would be stretching and the ability to recoil back. Think of that slinky that we talked about in the previous video. Let's see. In here, cartilages, which is not an easy word for me to say for some reason. Cartilages fibers. So again, kind of a more thick, durable. This is kind of like, this for the most part would be the underlying fiber of this tissue. And one more, oh yeah, we can't forget these cells right here. This one and this one, you know, all these things in here. These are fibroblasts. And remember, fibroblasts are important because they're the ones that produce the materials for all the different fibers. Fibroblast. Blast simply means it produces. Oh, that wasn't very good. Hopefully your penmanship is better than that. Fibroblast, it produces all the material for the various fibers that are within this, or anything. So that is areolar tissue. So let me slide. No, I don't need to slide. We're going reticular right here before I clear out my pen. We're going reticular right here. And let's get my box up here. Oh, that was almost well placed. Look at that by me. Of course, that was a complete guess there. Let's see what I got here. It's a package of reticular fibers and fibroblasts. Now, most anything's going to have those fibroblasts simply because it's what makes up. Helps produce the materials that I just mentioned for all of the fibers. So everybody's going to pretty much have fibroblast. Let's see, support. Lymphatic organs. Okay, so that means you're going to find them in places. I'm just going to put in and little hyphen there. You can't see the hyphen because my mouse is in the way. Let me move that out of the way. And so things associated with the lymphatic system, so like the spleen, lymph nodes. Oh, that's not the right letter. Lymph nodes. Make sure I don't misspell the thymus. And also bone marrow. Bone marrow, and again, that's associated with kind of that cleansing, healing aspect of everything. So that's reticular tissue. Let me click out of that right there. And let's look at our picture here. The reticular fibers, let's get my pen back up here. That's these thick, dark lines in here. So all these little thick, dark lines going through here. That's the reticular fibers. And of course fibroblasts and that kind of stuff in there. But those are the reticular fibers. So closing out my ink tray, let's slide everything up. And 2 down, 7 to go. So I hope everything's going well for you guys. And as I transition here, let's throw that out there. Adipose tissue. Okay, anytime you see that adipose, that word, that phrase, we're going to refer to fat somehow. And that's what all this yellow stuff is in here. Little fat bodies there. If you've ever dissected something, you've seen that plenty. You can open up, cat, rat, any kind of a mammal especially, and you're going to see that yellow stuff in there. That's the fat bodies. That's the adipose stuff. But let's see, what's it made of? Let's see. It's formed out of, let me get my little box here. And we saw this in our last video as well. Adipocytes, that's the cells that make up adipose tissue. So of course it's got to have that. And it's made up of, let me put composed. That sounds like a pretty cool word to use. Did I leave out? No, I got it. Areolar and reticular tissue. So along with, of course, fat and I'll move this over. Oh, not 2 D's, 2 O's. Lots of blood vessels. Okay, lots of blood vessels. And let's see, things that it does, provides. Of course, if you're talking fat, you're talking energy. And we're talking storage. 2 big ones. Insulation. Of course, I know all about fat being an insulation. I got way too much of it. And of course it anchors. Cushions organs. You know, kind of like a nice little pillow. A nice little pillow. So that's adipose. And let's see if I can't just do it this way. Yeah, that'll work right there. Same word, just relocated now. And of course, as I mentioned, get me a little ink tray here. All this stuff, all this yellow in here. So we'll point to several of them here. That's fat. Okay, we don't want too much. Okay, but in moderation, super important. Storing energy levels, all that kind of stuff. Insulation, helping to retain that heat. So even though we don't want too much, even though I have too much, it is a helpful aspect of our lives. So there we go. Let's see, cartilage. Cartilage. Oh, I got to flip the page over here. There we go. There's my cartilage nodes right there. Quick drink here. Alright, so cartilage. Let me get a box here. Oh, close out my ink tray. No picture this time. Sorry about that. Alright, cartilage. Alright, where am I? Oh, there we are. Alright, connective tissue. Cartilage is made of connective tissue. right off the bat. That's a big one. So because it is, we're talking flexibility, or flexible I should say, rubbery. If you've ever eaten, you know, like a chicken leg, chicken wing, that kind of stuff, that little white gristly, not gristle is what we traditionally think of, it's that white thick stuff. I mean, if you are eating a chicken leg, chicken wing, and you get that as part of your bite, you're probably not going to chew that up. You may even just spit that out or just swallow whatever, but pretty rubbery, difficult to break down with just teeth. Okay, some places you'll find cartilage, and obviously we know that it's part of the joints, but also in the ear. Okay, and oh no, there we go, comma, not period, and nose, kind of shapes that tip of the nose. Can't see it, but I'm putting my, speaking of can't see it, I'll get back to the nose. Decided to go full force on these videos. This is great, what I'm doing now, but it'd be nice to have a little picture of me there. That way you can kind of see my air quotes, you can see my face as I, just whatever. But anyway, so hopefully in the future, chapter 6 and whatever, I'm actually going to be up in the corner there. We'll see. Ear, nose, and larynx. Now, cartilage, and again, nursing students all over the room. So you guys probably know this, but there are three types of cartilage. And I'm probably going to run out of room here. I'll have to move that blood down a little bit. But three types. First type, hyaline, E right there, and hyaline cartilage. Let's see, what's some things we need to know about hyaline cartilage? Oh, it's clear, glassy looking. When you look at it from a microscope, and I probably should have put a comma there to separate those thought processes. What else we need to know? Let's see, joint movement. Joint movement, and what else should I throw out there? Oh, it holds airways open. So that would be the aspect of the larynx and that kind of stuff. So we're talking, if we're thinking it holds them open, that means it's pretty firm, dense, just, kind of almost like think of a PVC pipe. It just stays open. It doesn't collapse and go open, collapse and open, that kind of stuff. And let's see, what else I got? Oh, moves vocal cords. Yeah, I can't forget that. That's what I'm doing right now. And you're also probably doing it, except you're saying, oh my goodness, will he ever be quiet? No. My wife's been wishing that for a lot of years. Fibro is our next type of cartilage. Fibro cartilage. Fibro cartilage made of collagen. So again, thick, dense. Try to say those two words at the same time. Fiber, very good. Absorb shock. So if you think about it, absorbs shock, where would a good spot for it to be? Hopefully hands are going up all over the place. People are yelling at the screen. That's right, vertebrae disc. Vertebrae disc is where you'll find fibro cartilage. And our third and final type of cartilage, elastic. So if it's elastic, okay, again, we're thinking of that slinky. We're able to stretch a little bit, but then we recoil right back. Just like that old slinky that I mentioned last time. It's made of elastic fibers, of course. What else would it be made of? And let's see, flexible, as I mentioned. recoils, and you can find it. It supports the ear and the good old epiglottis thing that hangs down in the back of your throat. But nursing students, you knew that. All right, that is cartilage. And I'm just going to move blood down just a little bit here. All right, so that's 4 down, 5 to go. So let me slide these up. And there's 4 of them, and there's our 5th one down there, membranes. All right, bone. Now, when you think of bone, and I do have a little picture here only because I want to show you one part of it, and it's right there in the center. When you think of bone, the first thing that should come to mind, obviously the hard outer shell, and that's a compact bone or version of compact bone, but also the inside, because that's really where all the cool features are. You would think of if you just, picked up a nice femur bone of something. And of course, lots of examples in the, literary history of that being a pretty good weapon. It's pretty thick, pretty strong, and if you just held it in your hand, you're thinking, man, that's a good, solid piece of material right there. And you'd be wrong about that. Okay, there are lots of space inside, and it's not nearly as hard and rigid as you think it would be all the way through. And that's important because there's a lot of stuff going on in there. I mean, nothing else. You can see blood vessels going through there. Blood vessels couldn't carve their way through a hardened, steel pipe looking type thing, or iron bar would be a better way, not pipe. But let's think about bones. We mentioned you got that compact outside, the spongy inside. So let's get ourselves a little box here and get to showcasing some stuff about the bone. Let's see, there it is. Let's see, the tissue it's made out of is, make sure I get all these letters in the right spot. Osseous tissue. Okay, that's synonymous with bone. And as I mentioned, 2 types. The spongy, that's the inside part, and we'll just run all this stuff out here, and then probably have to move that picture a little bit, but we'll deal with that when we can. It's that honeycomb look, and when I say that, I'm going to close this and get this. I'm talking about this stuff right in here that you can see in this cross section here. And of course, it's all this stuff in here all around. Alright, close that back out. Yes, edit, because I'm not done talking. And that stuff is called, make sure I spelled this right. Alright, and that is, I'm just going to move this. There we go. Same word, just different location. And that word is right there and pointing to all this stuff in here. Yep, edit. Of course. And let's see, what else do I need to say about the spongy? It's the inside part, which probably doesn't need to be said, but just to refer to that. So that's all for that. Now the second type, compact. Okay, that's that hard outer shell. No, not O. That's the hard outer shell. I think, yeah, that's about it for compact. Thick, dense, if you want to, but those are all terms that you should be able to describe as far as a bone. And let's close that out. And that's the bone right there. So Just in case anybody's confused, this information goes with bone right there. Alright, let's talk about blood. Let's talk about blood right there. And lots of stuff here. Lots of stuff here. Lots of important components to mention. And as nursing students, you're probably well aware of all of this stuff. But it consists of fluid, not two O's, two N's, fluid connective tissue. So it's connective tissue, but more watery, as you can imagine blood would be. And got lots of things that it does. For one, it transports cells and other material. And I'm sure you're well aware, I shouldn't say I'm sure you're well aware, but you are well aware of that part of that transport, what it transports is oxygen. I would have just done the symbol, but it's not going to make the two the way it needs to look, so I'll just spell it out. And carbon dioxide. Again, same thing. I would have just written the symbol, but it wouldn't make the two the way it needs to look like. Alright, some of the components, I should say. Things that make up blood plasma. And of course plasma you're very familiar with and things it does, but it's the blood. Ground substance. So again, it's going to hold the tissue together. It's also going to hold the components together. But again, you've already done it possibly when I referred to ground substance earlier. But again, if you're not 100% sure, just refer back to your notes on ground substance as a reminder of what that is. All right, our next component. I always want to put a T first. But it's the Y first. Erythrocytes, and of course, red blood cells. Okay, super important. And of course, we got the leukocytes. And of course, we mentioned these in the last video. Those are the white blood cells. Big part of the immune system. And again, once we get, I shouldn't say we, it may be me, maybe Miss Nedler, but when you get to ANP2, you'll talk all about that immune system and all that stuff that's going on. And of course, saving the best for last, the platelets. Yeah, just didn't look right there. And that's where clotting comes into play. Okay, so that's some things about blood tissue. So, ladies and gentlemen, that is 6 of the 9. And so, let me scroll up here. Man, when I was thinking about all this stuff, I was thinking, man, this is going to take forever. But it's moving quite along, pretty good. And down to 3. So here we go, nervous tissue. Nervous tissue. A lot of cool stuff here. I love this chapter in the book and in the labs and stuff. Talking about the nervous tissue. But again, we're just going to introduce it. Super simple stuff. But man, when you get into ANP2 and you get to this section, actually it's the first one. The nervous system is the first system. So you'll go through the nervous tissue. You'll go to the brain. You'll go to the spinal cord and all that stuff. And it's pretty cool. I love talking about that. I enjoy that class. It's ANP1 is great. Okay, ANP2 is even better because it's all the good stuff, all the systems and organs and everything. A lot more dissection. But anyway, enough about all that. Nervous tissue, of course, we've got neurons, and you're going to get to see some artwork here. I'm about to draw your little picture. But neurons, as you know, send and receive signals, and how that works with the action potential and everything, that's phenomenal. I mean, I super love talking about that, and love drawing those pictures, love going through that math. I mean, you got the math involved, you got chemical reactions involved. It's pretty cool. I love talking about that, and you'll enjoy that as well. Now I'm talking so much about it, I hope it is me that we have A&P2 with, so because it'll be a great time. Another component are neuroglial cells. And these are super important. There's 6 of these, 6 types of these. And again, once you get there, you'll talk about all those. But they help support neurons. And like I said, there's 6 of them, and they've got some funky looks to them. We love looking at those. Pretty cool, almost like a sci-fi thing. The shapes are so odd and interesting. But like I said, there's 6 of them, and they do a different function. There's some that help support the blood flow in and around this area. There's others that are part of the digesting foreign material. You've got others that produce that myelin sheath that wraps around. It's got all kinds of great stuff. Love me some neuroglial cells all day long. All right, now for that picture I promised. And I got a little bit of room down here, so I'm going to draw it this way. But let's bring my ink back up here. Got my green. All right, so I'm sure you've seen this picture, or a picture. And but there's our axon, the 3 main parts. This is, we're going to call this an axon here. And then we kind of branch out into this kind of oddly shaped, almost like head-like, and this is going to be the soma. And let me draw the nucleus in here, color this in the best I can. This is supposed to be all within a darkened circle. So, but this area, that's the soma. That's like the cell body. Holds that nucleus. Okay, and then off of the soma, you got these little branch-like things here, and I'm just going to draw random things here. Put one up here. Those are the dendrites. D-E-N, den. Again, that's supposed to be a T there. Dot me some I's there. That's the dendrites. That's where the messages are received, the signals are received, and then they transport down the neuron. And of course, all this is a neuron, and it transports down. So the signal goes in this direction. So over here would be another neuron, and I'm just going to do NUE. I'll just do it all. It's only 3 more letters. Another neuron attached to the synaptic cleft, and then it would go again to the next. And I'll just put the word next over here. Next neuron, like that right there. That's supposed to be an X. So that's the idea with neurons and nervous tissue. So let's go over here to muscular. We're right here now. And let me close this. Bring up a little box. And move it up here. And we're down to 2. Here we go. Muscular tissue. Elongated cells. Okay. And let's see, stretch. Stretch and constrict. Okay, they're able to do that. Of course, that's not telling you anything you don't already know. But the big function, movement, and what else? Part of the digestive, digestion, breathing, speech. And there's supposed to be a comma in there. Not breathing speech, but breathing and speech. Okay, it also helps with the body heat. Yeah, body heat, body heat. Of course, I'm making this, as you can see, in August, so we ain't having no trouble with no body heat. But you know, come December, come January, come February, I'm going to be needing some of that, a lot of that. 3 types of muscular tissue. We've got our, which one do I want to do first? How about skeletal? Okay, skeletal muscular tissue. Now skeletal, boom, right off the bat, you should be thinking attached to bones. Okay, attached to bones, thread-like, long. Okay, I should have put long, I should have said long first. Thread-like, so we're thinking thin, okay, would be the way to think about that. And, voluntary, yeah. Got to mention that. Not T, how about a Y? Voluntary. So that means you control it, okay? I know it may seem like, and all the third grade teachers would agree with me, it may seem like that the hands and the arms of an 8-year-old boy aren't under any control. They're just kind of doing whatever and going whatever. But not the case. They are voluntary. You do control them. So, for the most part, I mean, there are some conditions where people cannot control that stuff, but that's a unique scenario, not the traditional process. Let's see, striations. Okay, if you're not familiar with that, that does not look right. Missing an A. I put a T there. There we go. All right, now we're still don't look right. Let me look at my words here. STIRATIONS. Yeah, there we go. Just didn't look right. Striation. There we go. And let me close this and draw a little picture. But striations are just simply, and I'm going to use 2 colors here. When you look at muscle tissue, it's got these, and let's go something really light. What's light in here? I got a yellow. Yeah, let's go with this yellow right here. And in between here would be light. So it's kind of a dark and light bands of tissue, and it gives it that striated look. In other words, it looks like it's got lines drawn in it because they're different colors. Striations. So when we get to smooth, smooth, they don't have that. Alright, so let me close this out. Is all this one thing? Can I move all this? Yeah, it is. Oh no. Let's see how good I am. Can I put it right back? Skill set right there. Alright, let's come back up here and edit that. So that's skeletal. Cardiac. And of course, as nursing students, you're already saying heart, heart, heart. Well done by you. Alright. Cardiac. So yes, heart. Let me put that on there. Not the band, which is the great band. Love me some heart. But we're talking about the heart organ. Is what we're referring to here. Striated again. And the way to think about that, anything that's gyrations, it's going to be a muscle that works. Okay, it needs to have some strength, it needs to have some power, it needs to have some endurance, some long-lasting stuff like that. Yeah, it's going to be things that actually move, expand and contract, constrict and contract, that kind of stuff. And let's see what else for cardiac. Where am I at? Oh, there it is at the bottom. And involuntary. Doesn't take much to realize that you would not want to control your heartbeat. If we had to do that, if we had to control that, that would just take up the entire day, because you had to be thinking all the time, heartbeat, heartbeat, heartbeat. We wouldn't get anything else done. It'd just be a mess. It wouldn't almost be worth having, because you really wouldn't be doing anything else. You couldn't forget. Had to be focused on that. And our last type, smooth. Okay, so again, we're going involuntary. When you want to think about smooth muscle tissue, it's anything that you don't control. Okay, any of those body processes. So like breathing. Okay, your lungs just working on their own, doing that stuff. Digestion, moving the stuff through the intestines, all that stuff. That's stuff that you don't control. If you had to think about, all right, large intestine, constrict, push that stuff along. Small intestine, constrict, push that stuff along. As well as your heart, and you just be sitting there in your chair doing that all day. And that don't sound like much fun to me. All right. And so basically, smooth, as I said, it's just pushing things, pushing material through the organ. And so we're talking respiratory, digestion, urinary, all that stuff. Let me put those on here. Urinary, respiratory, digestive, and go digestion, all that stuff there. Just pushing stuff through the organ, the system, whatever you want to call it. All right. Well, looky here, looky here, looky here. Our favorite topic of this particular video series, because it's our last one. And then we'll be done with human tissue. Yay. We'll be done with human tissue and then can move on to another great topic. But you know what? I got to flip the page again. 2.5 pages of stuff to talk about here. So here we go. Let me flip this over here. Membranes. Okay, let me get a little box here. A little box here. Let's start with lines, the body cavities. Now we've already talked about one membrane. We talked about the basement membrane earlier. So that's one that we have already mentioned. But there are 4 types. Okay, 4 types of membranes, and they each have super important functions, things that they do, and couldn't be without any of them. But our first one, the one you're most familiar with, cutaneous, that's your skin. Oop, not that. There we go. Largest organ on your body, the skin. Yep. Stratified, squamous. Let's go. Yeah, we can go out here because I got nothing over there. And plus, it's the last one. Stratified, squamous. So right away, you should be thinking multiple layers. Okay, multiple layers, and the squamous. That was the egg-shaped one, kind of shaped like eggs. And if you want to think about that, I'm going to put one more, and then I'll draw a picture. And it lies over connective lost where I was in my word. Lies over connective tissue. Oh, not two I's, two S's. Alright, now I drew this for you already last time, but let's do this again. Just to remind you, so if let's go back to green here. I got these layers stratified, and of course, this is the new cells, and again, they work their way up, maturing as they go, and when they get up here, this is when they die and fluff off, the old skin cells, skin debris in the bed, all that kind of stuff. That's where this comes from. Working their way up, and when they get to the top, okay, life cycle is just about over, and it just worked out through that process of moving up through, and a new layer is made, and those work up through, just like a big assembly line of skin cells. But in this case, it's membranes, and the cells evolve, or involved, not evolved. All right, so we want to edit because we're not done talking about this. That's just one of four. Okay, our next one, mucous membrane. So one right off the bat, you should be thinking mucus. So that tells you right away that these are passageways that have to be lubricated. So we're talking digestion, we're talking respiratory, whether it's designed to trap dust, help break down with the enzymes, all that stuff, the mouth area, the oral cavity. It is helping with that. Of course, it lines passageways. As I just mentioned, again, so respiratory, and I'm just going to put rest and digesting. Those would be the two main ones that would need to be constantly lubricated. I mean, it's understandable. You certainly don't want your intestines to get dry. You would not want that at all. That's type 2. 2 more to go, and then we will be done. Serious, and I mean very serious. I couldn't resist there. But serious membranes, this is the internal stuff now we're talking about. A lot of the mucocus, that stuff it leads to the outside, or there's openings that the outside can interact with. But the serous, that's the internal. We're talking simple squamous. So again, one row, okay, just a simple one row, or single row I should say, squamous cells, and it lies on top of areolar tissue, lies on top of that, and it produces serous fluid. And you're probably thinking, boy, I hope he tells us what that is. You bet I will. That digestion. Think about saliva. Think about the fluids associated with digesting your food. They're packing those enzymes, packing those things that need help with digestion. 3 down, 1 to go. Synovial membrane. Oh, I need that. I want this right there. Synovial membrane. And of course, these are joints. It lubricates. So thick. Okay, and of course it produces synovial fluid, and this helps, reduce friction. Reduce friction. All right, there you go. Membranes is in the books. Human tissues is in the book. Book it. Check the box. Put her away. It's done. So hey, thanks for being with me on this little journey. That was a lot of fun. Enjoyed the human tissues. Hope you did as well. And wherever you are, whatever day it is, whatever month it is, I'm sure it's the same year, because it's got to be, because the semester would have been over if the year changed. But anyway, much different time for you than what it is for me when I make them, as opposed to when you watch them. But that's the nature of the beast. Hope it's going well for you. Hope you're enjoying yourself. Hope you are, your semester's going well. This is chapter 5, so if you think a weekly, sometimes 3, so we're probably at least in the 5th week, possibly the 6th. More likely the 6th, maybe the beginning of the 7th. Who knows? But in there somewhere. I should have had my calendar out here, my schedule, our lab schedule out, so I could see exactly when you'd be doing this, looking at this. But anyway, enjoy yourself. Enjoy the rest of your day. Again, hope it's going well. Anyway, have a good rest of the time. And until next time, we will say goodbye.